Hello, it's me, and now we're going to continue our 2 by 2 by whatever series, 2 by x by x, 2 by x by m, who knows, by doing this 2 by 4 by 4 solve. I've done 2 by 4 by 4 solves before, but I'm going to be sticking with a little bit of a different style. I've kind of gone back to the basics as I've shown the basics of how to do a 2 by 2 by 1 puzzle, and then the basic algorithms of a 2 by 2 by 2. Now understand, the two basic types of moves that we do are moves of orientation, where we rotate a piece, and moves of permutation, where we take pieces and transition them to different places around the puzzle. So there's orientation algorithms and permutation algorithms. So that's all you really need to do, and I'm trying to simplify things as much as possible. When we went to the 2 by 3 by 3 puzzle, we added the notion of combining certain aspects, this in the middle and these on the top, where orientation is never an issue, but permutation is. And understand that with the orientation issues, all we had to do was the RIDIRD, because anytime you do 90-degree moves at right angles to each other, the end result of that potentially is rotating aside. The whole time permutating this is the notion of the law of cubes, of how many pieces I can move at the same time. So RIDIRD will cause orientation issues with this. One set, RIDIRD will bring this back up, but rotated. Can't do that without causing flipping of these guys and rotating as well. 3 sets of those will return the bottom right back to where it was, and if I don't move this, it'll return the top back where it was, which is why the RIDIRD works. I can do 1 set with this piece here, move it, do 2 sets with this piece. The end result is these guys will all be rotated, but this will be completely back to where it was. So that was a little trick of orientation. Permutation, I've just introduced the corner swapping algorithm, and we're able to apply that to a variety of puzzles. And when it comes to 2 layers, that's pretty much all you need, with the exception of the brick parity and issues regarding doing these center, these edge corner placed pieces, swapping those guys. I call them edge corner placement. So, getting to this guy over here, what's tempting to do is to do a reduction type technique and reducing it to a puzzle that looks like this. Now this has a 2-layer component here, but the majority of this is a 3-layer puzzle, and I'm not going to get into the exact details of that now, except just to introduce the fact that before we would cause a reduction of this puzzle to this puzzle over here. Now I'm saying there's no need to do that. There's no need to do the kind of reduction, because looking at this ceases to be a pure 2-layer puzzle in that you don't just have corners. You have true edges over here and true centers over here. You don't find that here. My contention is you don't find that here either. These I don't look at as edges. I look at that as corners of a 1 by 2 by 2 puzzle. These, you don't have edges either. I don't look at these as edges. I look at these as corners of an inner 2 by 2 by 2 puzzle. And even over here, I look at these as corners also, although they're more like corner edges, which I'll get into in a second. But these are true edges in that they go straight down to the core. They're not joined on either side by anything. An edge is something that's joined on either side by some central piece. In this case, it's an edge. Here, you could say, well, aren't these edges? And my contention is that they're not, because they're joined on either side by an edge, a central place piece here as well, but it's a hidden piece way down into the center. So I actually look at this puzzle here, this 2 by 4 by 4, as made up of all corners. This is an all-corner puzzle. All of these are corners. Let me explain. So let's take a look at a 3 by 3. 3 by 3 is the purest puzzle that has a single component, or as few components of each type of piece as possible. 4 corners, 4 edges, and 1 center is the bare minimum that you need to have all of the pieces in play. And they act differently. When solving a 4 by 4, somebody had the brilliant idea to take this puzzle, and even though these central pieces don't act like these, this is down to the core, these are not. There's a piece that's hidden that's down to the core. These actually are on either side of those hidden pieces in the center. To me, that's the definition closer of what a corner is. A corner is something that shifts on either side. These edges, well, they're not like this edge. There's a hidden edge underneath, and these slide over that. So these also act like corners. But if you look at it in a certain way, Because these pieces are in between corners, and because they seem to join two centers and two sides, they look a lot like edges. So the thinking is, let's take this, let's put all of these central pieces together and then call them 3 by 3 centers. Let's take all these edge pieces together and then call them edges and solve it just like a 3 by 3. The only problem with that is you're kind of taking pieces that aren't edges and aren't centers and calling them as such. And when you do that, that's where you end up with issues of parity, because you have a certain degree of freedom of movement between these guys that you don't have with this. So what I would say is that this entire puzzle is not made up of centers, edges, and corners. This entire puzzle is made up of only corners. Some of the corners are more specialized than others, but they're all pretty much corners. We can say that these are central corners, and these are corner edges, or edge corners, however you want to put it. But basically, this is a corners-only puzzle and can be solved as such. Let me explain further. So with this puzzle, you have algorithms that you only use for edges, algorithms that you only use for corners. We've gone through those. RID, RD for orientation, and the corner swapping algorithm for permutation. Here, we've got to do different algorithms, and we haven't even gone into that, and we won't go into that so much until we get into the 3 by 3 or 3 by X version of this Back to Basics series. But suffice to say, I only wheel this out now, even though it's not a 2 by 2, to state that this is a corners-only puzzle. Because what you can do is you can either reduce this to a kind of puzzle with pieces that just doesn't exist and then deal with the parities, which is perfectly fine, or you can do it parity-free. And the way to do it parity-free is to recognize that these are all corners and reduce every piece that this puzzle has when it's scrambled into segments of corners. Reduce it, in other words, to the structure of a 2 by 2 and then solve it as a 2 by 2. So instead of taking these pieces here and say that they're centers, and I'm going to reduce it as centers, just like the center over here, and say that these are edges and reduce it as edges, I'm going to say that every piece here is an aspect of a corner, a piece of a corner, a central corner, a corner edge, and then you have basically the outer corner. So what you can do is, instead of looking at this as a center and reducing it with its similar centered pieces, I'm going to look at it as a component of a corner, as a component of a corner piece, and reduce it in corners, and in so doing solve it like a 2 by 2 where you're just putting all the corners in. Among the different ways of solving the 4 by 4, there is a way to do it by reduction to a 3 by 3, in which case you're falsely identifying these as centers and reducing it as centers and solving it as such and just dealing with the parities afterwards. You can do it layer by layer and just deal with the top layer, or you can do it parity-free. And all parity-free means is that this is a corners-only puzzle with central corners, corner edges, and outer corners, and you reduce all of these into its respective corner and solve it as a 2 by 2. So that's really the concept with that, and you can solve any even layer puzzle like this. But let me prove that to you. If that's true, then every one of these pieces are also corners. And instead of reducing this to this puzzle over here and trying to turn these into centers and these into edges, I'm just going to say that all of these are components of corners, and as such can be reduced to a 2 by 2. If I do this, then I don't have to deal with certain nightmares that can happen with this particular puzzle. Now, I've gone through it before, but if I were to do a full scramble of this, a full shape-shifted scramble, the first thing that I used to do is I would solve the 2 by 2 component with just these corners, just defining them as corners. Then I would have to put it into the flattened form like this, the non-shape-shifted form, and reduce it down to a 3 by 3 by 2. Then I put the centers in, so to speak, and the edges in, so to speak, and deal with any parities. But in so doing this, I not only had edge parities, I also had floppy parities. The floppy parity had to do with the fact that I was trying to take it from a 2 by 2 solve just with these corners and try to put these into center and edge positions. So the floppy parity happened when you had pieces that were up like this and they had sort of a degree of bandaging, and I would have to bring them down. Well, now by looking at all of these as simply corners, every piece is a corner, and reducing it as such, I will run into no parities. So what I'm going to show you is a floppy puzzle that now has no floppy parities and no other type of parities of any sort, which you can apply to any type of floppy, not just even layer, not just even layer floppies, but also odd layer floppies too. So, how does that work? Well, let's start off with a scramble. So I'm going to do a 180-degree scramble along here, 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 here. Now I haven't gone into the details of how to solve this guy yet, but in order to solve this guy, you have to use edge algorithms. Well, we're not going to get into that yet. Here, you won't have to use any edge algorithms at all. I'm not even going to go through the edge algorithms in this part of the series as of yet, because you don't need them. All you need to solve a floppy now are moves of orientation and moves of permutation, just the way that we were talking about. Okay, a little bit more scrambling here. Okay, once I think I've got a pretty good scramble going on, I'm seeing too many of the same color here, so why don't I go like this, this, this. Okay, all separated out. Now we'll do the shape-shifting scramble. I'll just move this up over here. I usually like doing the layers over here, so I'm doing a nice little complete mess over here. And once I do that, I can start scrambling up to here, keeping it as symmetric as possible so that I can hold off on any bandaging as of yet. By the way, this was made by Ola Jansen, a designer extraordinaire. This is his incredible 4x4x2 puzzle. And once I've done that, I am now ready to do this scramble. Now take a look at what I'm doing here. This is now bandaged down to the point of being a 2x2. I can only make 2x2 moves at this point. Everything else is bandaged, so I've already got my 2x2. Okay, so pretty good. That seems to do the trick. Now, I will point out, you can make this puzzle by taking a 4x4, and if you have the skills, bandaging these together, so basically gluing these pieces together here, gluing the bottom two pieces here together, and shaving it down, doing whatever build-ups that you needed, and what you'll have is you'll have 2 layers here and 4 layers across, if you bandage these guys together over here. So you can make that over there. So if that's the case, then a 2x4x4 is really kind of like a bandaged and cut up 4x4x4, which means it's a lot like, well, another kind of a puzzle, which is a camouflage cube. So if you understand where I'm going with this now, perhaps I can solve it as a camouflage cube with an AI type solve. Now, to those who don't know what I'm talking about with that, that's okay. Some of you do. But here's what I'm simply going to do. What I'm going to do is I'm going to reduce this not to this puzzle over here. This has nothing to do with this puzzle. I'm going to reduce this to a 2x2x2, putting in all of the corner pieces where they're supposed to be, because every one of these pieces are corner pieces. There's central corner pieces and there's corner edge pieces. What I'm going to do is I'm going to use the same moves of RIDIRD in order to change the orientation of my 2x2 clumps, and I'm going to use the corner swapping algorithm to swap corners from one place to the next. As I'm looking at this here, notice how it's moving. I already have pieces divided into corners. So these 2 pieces, or these 4 pieces here, 2, 4, constitute a mixed up corner, as you can see. So it moves here, and moves here, and moves here. And you can divide the puzzle down this meridian and this meridian to get all your 2x2 components. So it's a 2x2, each one made up of 4 different corner pieces. 1 central corner piece, 2 edge corner pieces, and 1 outer corner piece. They're just not reduced in the proper fashion. So we're going to reduce this to the proper 2x2 by using these different specialized corner pieces. So what I'm going to do is I'm going to start off with a certain color, and let's say it's going to be yellow. But what I want to do is I want to take these outer corner pieces and match them up first off with one of the edge corner pieces. So if I'm going to start off with a yellow, let's start off with, say, this over here. What I'm going to do is I'm going to define a top part and a bottom part. This will be the top part, this will be the bottom part. And what I want to do is I want to be able to move this top layer because I want to move this green, orange, and yellow outer corner piece to an edge corner piece. So I'm going to look for the orange and yellow. But notice I can't move this here, I'm bandaged. So what I have to do is I have to take this clump here, this set of 4 corner pieces, central corner piece to edge corner piece and an outer corner piece, and I have to orient it in a way to where it's not going to bandage this movement. So all I have to do is flip this around by doing RI, DI, RD, RI, DI, RD. Eventually you're going to come to a point where you can make that turn. So now I can move things into position. And what I'm looking for is I'm looking for the orange and yellow. Let's see, an orange and yellow edge corner piece is right over here. So I'm going to move this in, line it up, and there it is. So you can see these two are reduced to each other. Once I do that, I'm now going to RIDIRD this so that I can move these two to the top where they're going to be conserved. So RIDIRD, RIDIRD. To those who've been following my tutorials, you know exactly what I'm doing and exactly where I'm going with this. But I still need to prove to you that there will be no parities. We have done away with floppy parities. That is a thing of the past. Now that I have that, I want to fill in these gaps over here. So what I'm going to do is I'm going to find the yellow and green edge, and I want to line that up with a yellow, well, I should say corner edge piece, and find the a yellow central edge piece. So where is the yellow and green? Here's a yellow and green. So what I want to do, well, actually here's a yellow and green over here too. So if this weren't moved in like this, let's say it was over here, so we just put this in. Now I want to take this and move this into place over here. But first I want to put it just below a central edge, a central corner piece, move it over here, and there it is over there. Now I'm going to RIDIRD this segment until it's down here so it can line up with this. So we do RIDIRD, RIDIRD. Now, here's the thing. I can try to move this in, but notice it doesn't match up, which means this is the wrong one. This is in essence why you're not going to get parity. You're not going to get parity because I can already tell, I can visualize what doesn't go with where, so I won't get fooled by that. Which means that this is the one. This is the green and yellow one, and I can move this in to see that it matches up over here. So I'm going to want to move this up top so I can join it to a yellow central corner piece over here. The problem is that if I move it up in this configuration, I'm going to be blocked by this piece. I won't be able to move this. It'll be bandaged over here. So I want to match this up with a top corner and central area where it will be able to make this kind of a move once I move it up. So I'm going to see where that can be, and apparently there's nothing here except this that'll do that. So all I'm going to do then is I'm going to take this bottom one here and move it up here. RIDIRD. The reason that I did that is now I can take this piece here and I can have this nice little 2 by 2 by 1 block over here. Because once I do that, now I'll be able to move this. I'll be able to move this without being bandaged by this piece here. So RIDIRD, RIDIRD. So that's this over here. So now I'm going to find a yellow one, a yellow central edge, and I don't see one up here that I can use. So I'm going to move it up from over here. So let's find another set that can move up to here. How about this one? RIDIRD. So I'm going to move this into here and turn, and bang, there it is. Now I move this one down, so I'm going to move this up. I actually didn't mean to do that, but that's okay. I can move this up. RD. And then put in the right configuration. DIRD. Keep going. Remember, 3 times will get us back where we started. Same things hold, and that's in. Okay, now that that's up, I'm going to take this green and yellow and move it down to this side here. RIDIRD, RIDIRD, D, and keep going until it's down here but can be moved without being blocked. Notice this is on a layer that cannot be moved to an upper layer. Or you cannot position an upper layer with it. Okay, so now that's here. So now I can take this, move it in, and bang, we're done. So this 1 by 2 by 2 block is done. Once I have this reduced, so this represents my first reduced corner. This is a reduced corner. I'm going to take this and I'm going to move it to the bottom, out of the way. R-I-D-I-R-D. Now I'm going to find another edge with a yellow. Well, there's this over here. This is yellow and red, so I can look for another yellow and red edge, which is right here. Thing is, I know it's the wrong one because it doesn't fit into here. So there must be another yellow and red edge, and that's right over here. So I'm going to take this and move it up to here. Remember, we're keeping this one that we just did down. So R-I-D-I-R-D. So it's up here, but I have to move it to where it's not bandaged out of the ability to move. R-I-D-I-R-D, R-I-D-I-R-D. Okay, move it here, and you can see this is now reduced. Red and yellow, red and yellow. I'm now going to move this top side so that it's free to move around with these two that's protected. So R-I-D-I-R-D. So I've added 0 new algorithms. Now what I need to do is I need to get this corner edge piece, which is red and yellow. Well, we've seen red and yellows before. We actually used it over here. I'm sorry, green and yellow. So where's a green and yellow? It's right over here. Now before I move this to the center, I want to put a yellow one, a yellow central edge over here. So let's see if we can move that in from somewhere. And aha, right here. So now that I have this here, I'm going to move this to this side so it can match with these guys. So R-I-D-I-R-D. So I'm not doing my 2 by 2 solve until I have all of my corners fully reduced. You can see this is in over here, move this in, and kersplat. So basically you have this 1 by 2 by 2 corner fully reduced. I'm now going to take this and move it down to this side with this guy here. So we have R-I-D-I-R-D. Okay, so now what? Now we've got a red and yellow. Let's find a red and yellow edge. I see one over here. So I'm going to take this and move this clump of corners up to here. R-I-D-I-R-D. Okay, it looks like this wants to be with this over here. So we're going to move this to here. R-I-D-I-R-D-R-D. Move it in and kersplat. So now we have these two here, this 1 by 2 by 2 block. Now we're going to move it to the top. R-I-D-I-R-D-D-I-R-D. For me, this is something of a fun type of reduction. And I had a viewer call this a master key strategy in terms of solving a variety of different puzzles like this. Blue and yellow. Let's see if we can't find that up here. Blue and yellow, blue and yellow. I don't see a blue and yellow corner edge here, so it must be down here somewhere. And sure enough, it's here. So I'm going to take this blue and yellow and move it up to this side. R-I-D-I-R-D. Now before I move that in, and we've got to bear in mind actually there's another one here. So which one is it? Is it this one? It would be nice because it already has a yellow central corner here. So let's take this clump and move it up here and see what we got. D. Okay, now let's move this in the middle there, the lower area of the top part. D-I-R-D, R-I-D-I-R-D. Move it in, and yes, we got lucky. So now we got this. So this is our third yellow corner that we've reduced. Now you can see these two corners here have kind of come together to show what it's going to look like. But don't start with that yet, but let's go ahead and take this and move it down. R-I-D-I-R-D. And, okay, so this, these are all in. So now we do the last yellow corner edge reduction. This one is already sort of found its 1 by 2 portion. So now I'm going to look for the other blue and yellow, and we know where that is, sort of. It's right here. What I'm going to do is find the yellow central corner, and it's this one here. So we got to move it into here, but we've got to turn this, because right now in this layer, because this is the 1 by 2 by 2 block that's here, this will not match up with this. So what we're going to do is we're going to have to move this around until it finds its way here. The only problem is that I've got to be careful. I have to make sure that it's got a 1 by 2 by 2 just above this, or else I'll be bandaged. This is not bandaged here, but if we move it here, it will be bandaged. So now we'll move this in its proper configuration. R-I-D-I-R-D. By proper configuration, I mean a configuration that it can bind with this. It can match up with that. D, R-I-D-I-R-D. Okay, move it in, and there it is. Let's move this to the side down here. So we're going to move it into this layer. R-I-D-I-R-D. Now you can solve this any way you want, whichever you find the most fun, but I'm sticking with my 2 by 2 strategy and my whole parity free aspect. Move this here, and bang, there it is. So now I can move my last corner, my last yellow corner down here. R-I-D-I-R-D. Now if I wanted to, I could solve this bottom layer, but I'm not going to do that yet. Really doesn't matter to do that as of yet, because we're not doing our 2 by 2 solve. So now the top layer, well, this is going to be easy because I've taken all of my yellow my yellow central corners and put it down here. So I'm just inundated with white central corners up here. So all of these edges are automatically going to be with the proper color here. What I want to do is, you can see we're bandaged here, and we're bandaged by this segment. Let's go ahead and move this to where it finds its way up. So R-I-D-I-R-D, R-I-D-I-R-D. I'm just unbandaging the whole top layer here. R-I-D-I-R-D. Okay, so you can see this moves over here. Now this is a lot simpler than you think. All of these edge corners here, these corner edges, are going to automatically be with the proper central edge color. We've already fixed that. We just have to put these outer corners in. So I'm going to look for a red and white, and right over here, red and white. So let's turn this in. Right over here, red and white. So now what I'm going to do, now notice a couple things happened. This is in, this is also in. So we've got these guys matching up, the 2 blues and the 2 reds. So I'm going to take this and I'm going to move this up and this up. R-I-D-I-R-D. Matching is incredibly easy with this, and I would even say the floppy puzzles are easier than camouflage cubes because the bandaging is very predictable. R-I-D-I-R-D. So a type of cuboid that was amongst the hardest becomes the easiest. So these 2 are up here. These 2 are automatically reduced down here. And now we just have to look at these 2 corners here. So this is another white and blue. So I'm looking for another white and blue edge, which is over here. So what I'm going to do is match this to here. And there it is. So I'm going to move this top side. R-I-D-I-R-D, R-I-D-I-R-D. Keep doing that. R-I-D-I-R-D. Okay, and now we have just to put this orange and, orange, I was right for once with that, orange and white with the orange white over here. So I just turn this here, and now this last odd one out is in, so I'm going to move this to the top. R-I-D-I-R-D, R-I-D-I-R-D. Now, let's take stock on what we have. We have reduced 1 by 1 by 2 bars everywhere. This is in all these top corners. Outer corners are matched up with the proper edge corner, and all these bottom edge corners are matched up naturally with their central corners. Now all I have to do is match these guys up. So this green and red can come over here. So this corner you can see is in, and this corner is in. Now all we have left is to match these guys up and coordinate them. This can come over to here and be all matched up, and this can come over to here and be all matched up. But how do I match these guys up without destroying these two and one of these? I can have two of these in and both of these out, or I can move this here, have one of these in and all three of these out. Well, the way to do this is to coordinate it with a corner swap. So I've been using orientation this whole time to orient these segments in the right place, in the right way, so that I can do my proper turns. Now I'm going to do permutation so that I can cause the proper swapping around. So the way that I've always done this with AI cubes and camouflage cubes is I'll move this one in to where it's supposed to be. Once I've done that, I now move it once out. So I go one beyond. Now if I do one corner swap, see what's going to happen. All of these segments here and these segments here, this entire block and this entire block is going to swap. When it swaps, then this will be here and this will be here. I just have to do one more UI move. This will now come into where this is supposed to be. And this green and white will come where this is supposed to be. So one more move will get all of these guys in. So just to reiterate, put it in, move it one more, and just do a corner swap. Now that's how you do it by rote, but you can calculate it and figure it out. What kind of corner swapping do you have to do so that one move will get all of these upper layers matched with the lower layers? So we do a corner swap to our U, to our UI, to R, turn the whole puzzle 90 degrees counterclockwise, to our UI, to our U, to R. And then you're going to find that magically all you've got to do is go one more, this is in, this is in, this is in, and this is in. Now if you couldn't follow that quite well, that's okay too. All you have to do is just look around and see what kind of a corner swap will get all of them in. Because of the parity of this puzzle, you know, how it's organized, you will find at least one configuration that'll do that. So what I have here now is a fully reduced 2x2 puzzle. That's all this is now. I've reduced all of the corners. I didn't do any false center reduction or edge reduction. I just did pure corner reduction with all my different corner types: central corner, edge corner, corner edges, and outer corners. So to solve it as a 2x2, we'll start off with a yellow layer down here. What I'm going to do is just move these in over here, and I'm moving it exactly like a 2x2. I'm just going to find proper corners, bring this up here. And now this is going to come over to here with an R-I-D-I-R-D. So you can see the bottom layers here. Don't worry about the shape shifting. All the shape shifting means is how these separate corners are oriented. So in terms of orientation, speaking of which, I need to take all of these whites and move it up to the top. So to do that, it's R-I-D-I-R-D. So you can go ahead and count with me in terms of how many you have to do. 3 sets of R-I-D-I-R-D, regardless of where I position this, will get the bottom back. So let's move this up with as many R-I-D-I-R-Ds as it takes. R-I-D-I-R-D, R-I-D-I-R-D, that's one set. R-I-D-I-R-D, R-I-D-I-R-D. That's 2 sets, and that's fine. I'm going to move this over here. Now I know that one set is going to move this up and is going to get my bottom back. And then we do the same thing with this side. R-I-D-I-R-D, R-I-D-I-R-D. That was one set. This is all back in, and this is fine over here. Now I do the next one, same thing. Move this up, R-I-D-I-R-D, R-I-D-I-R-D. That was one set. Move this in here, and now you can impress your friends by saying, I don't even have to look at the puzzle. 2 sets of R-I-D-I-R-Ds will bring this whole puzzle into a solved state. R-I-D-I-R-D, R-I-D-I-R-D, that's one set, and as scrambled as it looks, we simply go R-I-D-I-R-D, R-I-D-I-R-D. Well, I kind of jumped the gun. It's not the whole thing it has been solved, but this is now all in the proper orientation. With this in the proper orientation, all we have to do is get the proper permutation. So we look here, just remember what our 2x2 sides are. Find the 2 overall reduced corners that are in. So you see both of these blues are in. We'll move this to the side. And now we do one more permutation. Orientation has been achieved. Now we do permutation by doing a corner swap. To our U, to our UI, 2R, rotate, 2R, UI, 2R, U, 2R. This is all fine, and we just move it in and done. So there it is. A floppy 2x4x4 solve without a floppy parity, without any parity at all, because we were just reducing these into corners and solving it just like a 2x2. So I want you to consider exactly the magnitude of what I'm talking about. This is a parity-free solve because of how we're conceiving this, how we're viewing what this puzzle is, that this is a corners-only puzzle. This is a corners-only puzzle. Now, as you get to larger cubes, it just might be faster to do the reductive method, and that's fine. But if you want parity-free, if you hate parity, you can do that by looking at these pieces truly as they are. This is not just a quasi-form of a 2x3x3, and to be reduced as such, this is a corners-only puzzle. Now what I'll tell you is you can take any even layered puzzle that's purely even layer and solve it by this kind of reduction and completely avoid most, if not all, parities. Bricks, sorry, you're going to probably deal with brick parities. But here, you're going to be able to avoid any floppy parities. You can apply this to a 2x2x4, you can apply this to a 4x4x6. Any of these will do with floppies. And actually, as we get to even layer, if we get to odd layer floppies, we can do the same thing. You can actually avoid any floppy parities with that. So to those of you who have modded or bought or have a 2x4x4, pull it out and give this a try. Completely avoid those parities. Now, in terms of where we're going to go with the final parts of our 2-layer solve, just using those 2 algorithms, and again, floppies only solved by 2 algorithms this time. Can I challenge myself by bringing this beast out? The 2x4x6. We've done our 1x2x2, 2x2x2, 2x2x3, 2x2x4, and 2x4x4. What about 2x4x6? Can I define all of these the same way as everything here are corners, just different subsets of corners, and solve it using the same technique and completely avoid any floppy parities? This is an ultimate shapeshifter. In an ultimate shapeshifter, if you solve it by the usual methods we were talking about, you get every kind of parity. Brick parities, floppy parities, all of that. Perhaps we can avoid all those parities by using the same process. So what I'm going to do next is see in our last 2x2x2 type video, see if we can challenge ourselves by doing the same thing with a 2x4x6. Let me know what you guys think of this as we continue. Thanks for watching.